Hi, everybody. Last time I had recorded a video about this agent right here, the Linux patch prep agent. And the whole idea and thought behind this agent was to execute a patch report and some pre-checks on some Linux servers, and then just render an HTML report that would notify people and our users and the agent consumer of the status of these servers, right? How many updates do they have, critical services running on them, etc. So I went through and I was actually looking through some of the possibilities and the ideas of kind of operating this, and I came up with the next thing, right? So going into and looking at, okay, how can we break down this process to see if we do the patch prep and then we do the actual patching itself. So I have two agents today to show you here. And if you look at, there's a prefix here that says LCM, and let's look at the initial agent, which is the preparation agent. So I have redesigned the process a little bit, and rather than just being reporting, we're actually going to go and execute the patching pieces itself as well. But what's different now with this setup is we got a patch prep agent here. I actually got to redo this system prompt here. I just realized it doesn't have it. Let's go and fix that actually. So let's go patch prep. So it's a patch prep agent. Here we go. So what this agent will do is it has 3 steps total in its set of responsibilities. The first thing that it'll do, it just like the previous flow, and I'll link it here. There was a separate video done for that. It'll run the patch report and execute the pre-checks. That it's all one tool. It's a workflow in the Itential platform. I went into it in kind of detail. We'll go through it during the execution here, but I don't want to focus too much on the tools themselves and the workflows. I want to focus on the 2 agents and kind of what they're doing. So agent number 1 will run the report and execute the pre-checks. We'll extract the data. It'll evaluate what servers need patches, and then the status of the pre-checks, if they fail or pass. Then what happens is we're going to be integrating Lifecycle Manager in Itential. Lifecycle Manager in Itential, it's used for instance and resource modeling. And in those resources, we get to create instances. So what the idea here will be is that we're going to model the patch status of these servers, of these VMs, of these Linux devices. And then we're going to capture certain data as part of those instances. So as part of step 3 here, we're going to be syncing to LCM. We're going to get all the instances. The agents, it's all going to do this during its own thought process, right? There's no workflow for that. There's the workflows that do the particular tools, but the logic is all done by the agent, the reasoning. We're going to provide all the instances available in LCM, check if the server exists. If it's not found, then we're going to go execute this table, this decision table. If the instance is not found, we're going to create it. If it exists, we're going to update it. If it exists as no changes, then we skip it, and then we're done. That's the responsibility of this agent. So let's go ahead and run it. This will take a minute to run. Once we start executing this, we should see some stuff going on. Yeah, here we go. So the first tool call goes through, and that's going to be this workflow, which we looked at last time. Same identical workflow. And I'd say last time, as this was done on the previous recording. Let's see if I can collapse this here. I can't quite get to that on my screen. Collapse. Here we go. There we go. So we went through this last time on the previous recording, so I'd recommend watching that. Essentially what this will do is it'll do the patch check on all the hosts that are in the inventory. The inventory exists in a repo. It'll be pulled all real time by the service execution. That's all part of the other explanation. We'll get a patch report, which will be used. The patch report is not useful here, but we'll just have it. It's the same workflow, so we're just running through all of it. And then we're going to execute the server pre-checks. Once that's done, we're going to go here, and that is my agent. There's somebody's doing something else. Let's go. If I can go back, let's just go back here to our active jobs. Okay, so I want that active jobs there. Okay, so let's go here and see. We got a lot of stuff that went through. What I want to know is we went through those. We went through the tool call, run patch reports. We got a bunch of information back. Okay, here we start getting into the interesting stuff. So this is the analysis of the data. Step 2, extracting results. Servers needing patches. So the agent has identified that there are 3 servers that needed patches, right? Just like last time. just different numbers because I did patch those during testing. Needs patching 7 updates, 10 updates, 1 update. All the pre-checks have passed, and now we're gonna go syncing, doing the creation in LCM. Yeah, I want to do all 3 tools. It should have on my tool history here, and everything is good. So here we go, and then we get some details and a summary report. That's perfect. So if I go to Lifecycle Manager now, I have 3 instances of those servers. It was empty before. I had cleared out the list before starting the recording. And if you look at the last action was create at 3:18, which is when I'm recording this, 112, 3:18, 39. And we got properties. So these instances all have data here that we've saved. Now the agent has done all this stuff, right? The model itself models certain data. It'll model the host name, the patch status, the updates, the pre-checks passed or fail, and then the status. These messages come as some instructions and useful data, like the OS, IP address, and so forth of the host, but it'll do this for all of them. So we're actually using the agent reasoning to capture data from the output and mapping it to the model in Lifecycle Manager. And the model is actually just modeled as a schema. So here we go back. If we go, kind of look at the nitty-gritty details of the model, this is what the model is. It's a JSON schema, and this is the data that we're modeling, right? So we're using the agent to reason through the data from the patch and mapping it to this data model. So now that we have this data accumulated for all these hosts, now we know there are 2 hosts, Kafka and MySQL, that need patching. So now we're going to jump into agent number 2. And the whole thought behind this is that we're going to break up this process, right? We're going to do evaluations. You could run this agent on a schedule every day at midnight or every week or something like that, and then figure out, okay, we're going to keep my Lifecycle Manager table updated with the latest status and patches, and then I can run my patch agent, once a week or something like that, right? So now we're going to go to the logic of the patch agent. So now what this agent will do is it'll continue and tag along on the information that the previous agent populated. It'll go to LCM, get all the instances, extract them all, right? We're already doing some cleanup, right? This is a tool that I've created. It's a workflow. I'm doing some cleanup on some of the data. That way we keep the context, small in the agent. With evaluate eligibility, the servers need to have patching true, right? It needs to have patching and ready to patch true. That means, the pre-checks are good and everything is good. Step 3, we're going to call the patch servers with an array of qualified server names. Then when we're done, we're going to run the patch report on the results, and we're going to extract the reboot recommendations. Now, this is the important thing, and I've passed the piece that I have not run yet, so we'll see what happens. I have not tested this yet because it's very difficult sometimes to figure out what servers need reboot or has reboot recommendations, so we'll see how that goes. We're going to create a change request if needed, and we're going to see that. So if there's a reboot recommendation from the patch report, and this is all where, I got an Ansible playbook that does all this, that does some of the patch pieces. And then I have a workflow that does, some of the logic, etc. Right? So this is combining the power of Ansible plus Itential plus putting FlowAI on top, using all those workflows as tools. So we're going to keep combining all these things. So we're going to go create change requests if needed, and then we're going to go update Lifecycle Manager with the status, send the notification. So I should get a Slack here, and I'll try to show the Slack at the end. And then we're done. So let's go ahead and execute this thing and see what happens. Okay, so we're running a patch server flow now. This patch server is this is a very simple tool call. This is just calling an Ansible playbook. So we'll see how long that takes. It'll take a minute, so I may have to pause the video here and kind of jump to the end, but we'll see. Okay, so our agent finished, so we'll see. Let's see what went on here. Okay, so we got a lot of tool calls, a lot of messages. The first 2 we know, those are prompts, user prompt. I said evaluate all SCM instances. We do all that. We extract the data. Let's see, evaluating eligibility. So effectively, the agent has identified there are 2 servers that need patching, my Kafka server and my SQL server. It called the tool to patch the qualified servers. It's got a bunch of output. This is probably from where most of the context comes out. So I can do some cleaning up in here and actually cleaning some of that data. That way the agent doesn't have to process all that. The patching completed successfully. It's going to run the report again. Like we looked at agent number 1. It's going to check the reboot recommendations. Ah, awesome. So it found the post-patch report shows SELab MySQL up to date. Pending kernel upgrades requires a reboot. So SELab MySQL requires a reboot due to a kernel upgrade. Creating ServiceNow change request. It says that it called, created, it's doing a tool call. For ServiceNow, I keep hiding these. There we go. 11. It created the change request. This is change request. That's fantastic. And let's see what else it did. So it went ahead and created, let's see what else it did. 11. Create the LCM instance. It did all that. It did all that. So the tool calls are being split here. And then it also sent a Slack notification, which I'd asked it to do. And that's awesome. So let's see, Linux patch server patching complete. And this is it. Okay, so we got a Slack notification. Linux patch server patching complete. 2 servers patched successfully. SELab Kafka, pre-patch status, all servers up to date. SELab MySQL requires a reboot. Change request 3750 created. Schedule reboot for the next step is schedule reboot for SELab MySQL to activate kernel upgrade. So this is fantastic. This is kind of what I want to see. This is what I wanted to see. And I'm very happy because I did not get to test the change request creation before. I mean, I had a workflow that I know works, but now we're going to go into ServiceNow change table. It was 35760. Here we go. Reboot required for SELab MySQL after kernel patch. Let me go. Come on, ServiceNow. Okay, let's go here. So let's see. Reboot required. Impact low. Post-patch analysis indicates that SELab MySQL requires a system reboot to activate new kernel version. The currently run kernel is da-da-da-da-da. And let's see if it puts some notes in here. Kernel upgrade completed on SELab MySQL. System reboots required to load the new kernel. The change request tracks the pending reboot action. That is fantastic. That is a fantastic outcome. So now I just demonstrated very quickly, and this is without even leveraging a lot of the capability from Lifecycle Manager. Mind you that I could actually have the trigger for each one of these and being tracked separately in Lifecycle Manager, and also implement actions against them. I'm just using this as pure data modeling at the moment. But the one thing that I do get by just doing this, which is very, very mundane use of this tool, I also get tracking of the status of each one of these. So we have the create and the update. One thing that notice here, this is all done by the agent, by the way. The create was done by the agent number 1, which is the first one that we executed. And the update is done by agent number 2. Look at how we get that diff of those objects. So we get, hey, the server wasn't needs patching status 9, it's an up to date. This is status warning. And upgrade kernel requires reboot. And if you look at Kafka, which doesn't have that warning, it should be in up to date, ready state. Patching completed successfully, 7 patch applied, 3 updates remaining. So these messages is just an empty array that we have. We could have it be cumulative and say, agent, just don't remodify that, just add on new messages to it. Just have it as a kind of an empty. We have it for the agent right now to kind of populate whatever data it wants. But this is pretty awesome. Pretty happy with the outcome here. There's a lot of stuff that can be done. I could have this be a multi-stage process, right? At least we got 2 stages right now. We could do multiple, 3, 4, 5, and just leveraging the tools that I have within the platform here, right? I've not stepped out of the platform to do anything aside from having that Ansible playbook ready. But you can kind of see the stuff that I can do once I get these things kind of plugged together. Thanks for tuning in.